In the previous part of this series, we looked at the integral dx by 1 plus e to the power x and compared that with this other integral that we are calling integral b, integral dx by e to the power x. Although they appear to be somewhat similar in form, we realized that their graphs or their plots, they look quite different from each other. Despite that, can we make use of how b is solved in order to solve a? That's the question. So the first attempt at a can be set the denominator, which is 1 plus e to the power x, and call that to be t. T is equal to 1 plus e to the power x. We are trying to substitute a variable t for the denominator 1 plus e to the power x. And then we realize dt is equal to e to the power x dx, but we don't have a numerator which matches up with this dt. So that does not really work. That substitution did not really work. Okay? Let's go back to how we want to solve b. For b, what we do is, well, for b also there should be a similar problem if we substitute t is equal to e to the power x. If we substitute, say, t is equal to e to the power x, then again dt is equal to e to the power x dx, and again the numerator just does not fit that way. And that is the case, we don't really solve b in that way at all. What we do is, we essentially multiply both the numerator as well as the denominator by e to the power minus x. That is, e to the power minus x dx by what happens to be, therefore, equal to 1. And this is, of course, we know this is equal to minus of e to the power minus x plus constant, plus the arbitrary constant. Okay, so that is the way b is solved. Can we apply a similar idea or this trick of multiplying the numerator and the denominator by e to the power minus x to the integral a? Let's try this. So suppose we want to multiply both the numerator as well as the denominator. What we get is e to the power minus x dx by e to the power minus x times 1 plus e to the power x, which is equal to integral e to the power minus x dx by 1 plus e to the power minus x. Now we again try the same substitution. We substitute t is equal to 1 plus e to the power minus x, and now voila, we have dt is equal to minus of e to the power minus x dx, which is exactly what we have here. Well, with if we allow ourselves to forget the minus sign, which we can anyway pull in, right? So therefore, given that this integral looks like is equal to minus of integral dt by t, which is now a well-known integral. This is nothing but minus of ln of t plus c, where ln is, in places they call it ln, in some other places they call it lan, is the natural logarithm of a number t, log with the base e. Okay, log to the base e. That's what ln is. So this is nothing but replacing what t is, minus of ln of 1 plus e to the power minus x plus c, and we are done. Although we were able to solve by analogy with what we did with this other integral, integral dx by e to the power x, there seemed to be at one place a bit of magic. The magic was when we were multiplying, the magic was sort of in this step. The magic was sort of in this step, where we multiplied both the numerator as well as the denominator by e to the power minus x. In the next couple of installments, we are going to explore a couple of more methods to solve the same integral, which may appear less magical as compared to this. Thank you.